So, I have a problem. It says, which expression is the correct simplification of x times x squared to the power of negative 1/2?
Okay. X times x squared, all of it to the power of negative?
No, just the x squared. Just the x squared is to the power of negative 1/2.
Okay. It's like that. So,
but multiply that by x.
The whole thing?
Yes.
So the x is not under that exponent, only the x squared is. Okay. Well, there's two things we need to talk about here. And one is what you do when you have, I used to call this double exponentiation. It actually isn't, but it's being exponentiated twice. So how do you handle that? What is that equal to?
What do you
do with the exponents?
Multiply it.
Yes.
Multiply it.
You multiply them together. And what you get when you do that is that, correct?
Yes.
Okay. Now let's talk about negative exponents. What does this mean?
You're dividing?
No. A negative exponent merely means the reciprocal. In other words, it means 1 over x to the 1. Okay? If I had x to the minus 3, that would be 1 over x to the positive 3.
Yeah.
And you can always just move it to the other side of the fraction bar if you're ever unsure. In fact, if you had something like this, it's already in the denominator, just move it to the other side.
So you reciprocal, so you switch it around.
Yeah, exactly. That's what negative exponents mean. The reason people get confused is the moment they see a negative sign, they think it's got to be a negative number. And it is not. Okay? Yeah. So how else can I write this? This part right here.
So x.
1 over
x.
Okay. And now what can I do? What's x over x equal to?
It cancels out to 1.
Equal to what?
1.
Okay. It does cancel, but that's really not the proper expression. What you're doing is dividing both sides by x, the top and the bottom by x.
Okay, yeah.
And any number over itself is always 1. Now notice there was something we actually could have done without using the negative exponent aspect. What do you do when you are multiplying the same base, different exponents? First of all, what's the exponent of that leading x?
1.
Now, when I'm multiplying, what do I do with these exponents?
You add them.
So what does that give me?
0.
X to the 0.
And then x to the 0 is always 1. Anything to the 0.
Anything to the 0 is always 1. So I can get there without actually doing this step here. But I just wanted to make sure you understood how to handle negative exponents.
Okay.
So tell me what this is.
So that would be 1 over 2 to the 3rd.
And what's 2 to the 3rd?
8.
So that's 1/8. See, that's a positive number, even though it's a negative exponent. So, all right. What else you got?
So the square root of 8 over the square root of 5.
You said 8?
Yes, over the square root of 5. And then for the square root of 8, you have to put a 3 for like the cube thing. Like this cube.
It's the cube root of 8.
Yeah, the cube root.
Okay. Yeah, whenever you are writing the radical sign like that, there's an implied 2 right there.
Yeah.
This means square root.
Okay.
So if you're going to take third root, you need to write a 3. If you're going to take the fourth root, you need to write a 4, and so forth. Now, the bottom is just the square root of 5?
Yes.
Okay, what's the top?
The cube root of 8.
What's that equal to?
2.
What's wrong with this answer?
It's not simplified.
Well, it's simplified, but it's got a irrational denominator.
Okay.
Mathematicians do not like irrational denominators because when you're dividing, you're splitting something up into a certain number of pieces. And square root of 5 cannot be splitting anything up into a same, because it's not, in other words, it's the square root of 5. I can approximate it with a decimal, but that's not as good. So, to solve this problem of having an irrational denominator, what do we do? It's called rationalizing it.
Rationalize.
How do you rationalize something?
You solve it? I don't know.
What I'm allowed to do with any fraction is to multiply it by the number 1 without changing its value. I can always do that. No matter what the fraction is, I can multiply it by 1.
Okay.
Well, my 1 in this case is going to be this. That is the number 1, is it not?
Yeah.
Okay, in other words, that is the number 1. And multiply straight across. So what do you get for the new numerator?
The square root of 10.
No, it's 2 root 5 is the way you say that.
Root 5.
And then what's the bottom? What's the root 5 times root 5?
Root 25.
Or?
5.
Notice we've got the same exact number because I only multiplied it by the number 1. I didn't change its value. But now it's got proper format. In other words, we are dividing by a rational number, the number 5. So this is the preferred way that they want you to write it.
Okay.
And that's usually the case whenever you have an irrational number. Unless it's like pi, you can't really rationalize pi. So if you have 2 divided by pi, there's no way to rationalize it. If I multiply it by pi over pi, I get pi squared in the denominator, and that's not rational either. So there are some numbers where you can't help but listing an irrational denominator.
Okay.
Yeah.
So I have another problem. Okay, so just to clarify, to find an arithmetic sequence, like the equation, it would be a n equals a to the power of 1 plus n minus 1d. To find an arithmetic sequence, is that right?
Whoops, hold on one moment. Okay, so let's talk about 2 types of series. Arithmetic and the other is geometric. Have you
Yeah.
had geometric yet, or just the arithmetic?
We've learned both, but like we're having our final this Friday, and I just want to go over it.
Okay, you want to go over both or just this one?
Well, both.
Both, okay. The general formula when you have an arithmetic sequence for the nth term, and that is pronounced a sub n.
A sub.
A sub. It's a subscript. Okay?
Yeah.
And it's equal to a sub 1 plus n minus 1 times the common difference, d.
Okay.
Let's take a sample of an arithmetic sequence. How about 1, 4, 7, what's the next number?
10.
What's the next number?
13.
That's what defines an arithmetic sequence, is when they're all separated by the same number. So that, what is D?
3.
Okay. So, let's check and see if this works. Let's first of all, this is a sub 1, this is a sub 2, this is a sub 3, that's a sub 4, and that's a sub 5. So down here on the right, let's just make sure our formula, it works for a sub 5. So tell me what to fill in. What's a sub 1?
1.
Plus, what's n?
5. Minus 1 times 3.
Okay. So let's calculate what that is. That's equal to 1 plus 4 times 3 is equal to 13.
Okay.
Okay, which is correct. So that verifies that we've got the right formula. This is where you start with all problems of this nature. Usually is this formula right here. Unless they're asking you for the sum of the sequence, and then there's a sum formula. But I don't know if you've gotten that far yet or not. Notice what we could do here is answer a question that would be very tough to answer. What would you think a sub 273 would be? Notice that if I were to do this manually, I would have to do this 273 times to figure out what it was. But if I use this formula, I can get it real quickly. It's equal to 1 plus 272 times 3. That number I can get in an instant.
Yeah.
So that's the beauty of sequences, where you can have a general formula that tells you the nth term. Now, do you have a specific problem?
So it was -4, 0, 4, and 8.
And they want this general formula for this sequence, right?
Yes.
Okay. So what we're going to need is, what's a sub 1?
-4.
What is n? Oh, hold on.
Yeah.
I'm not going to solve n yet, because they didn't ask for the fourth term.
Yeah,
we do need d. What is d?
4.
Is it positive 4 or negative 4?
Positive 4.
And it can be negative. Doesn't always have to be positive. In this case, it is indeed positive. Okay?
Yeah.
So if we try to write the general formula for this particular sequence, because each sequence is going to have a different formula, but they all start with this general formula. So it would be what? A sub n equals
-4 plus n minus 1 4.
Okay, now we can simplify that, and you always will be able to. So what's the first step in simplifying that?
Add it, doing the parentheses.
Okay, how do I do that? What should I write?
-x.
Well, the only reason this is difficult for you is because the 4 is on the wrong side. Let's put the 4 on the other side.
Okay.
Now distribute it.
4n minus 4.
Now simplify it.
an equals -8 plus 4.
Yeah, and I believe that they usually write it like that. They put the n first.
Okay.
When you have a variable, that's usually what you do. Okay? So here's my formula for this sequence only. And notice that well, what should the fifth term be?
12.
And what does this tell us the fifth term would be?
12.
So that's the check to make sure you've done it correctly. In other words, if this isn't the right answer, you won't get 12 when you do it.
Mm-hmm.
All right. You have another one?
I have a different problem.
Okay.
So for an exponential equation.
Okay, we're covering a little bit of everything today, huh? Okay.
So if you're given points, so the question.
Not quite understanding what you're saying, Rithika. Please.
Okay,
Can you repeat?
choose the correct equation for an exponential function with initial value 0, 2 that passes through the point 3, 16.
Okay. What is the standard format for an exponential equation?
Y equals AB to x.
Notice the x is in the exponent.
Yeah.
Which is far different than when the x is down on the algebra line. When I have a function like this, my variable is on my algebra line. That is an algebraic expression. This is not. This is an exponential expression. And you cannot solve these algebraically. There's no way to solve them algebraically. You have to solve them using things like logs and stuff like that. I presume you haven't had logarithms yet?
No.
Okay. That actually follows this, but they're starting you on this. Okay? An exponential usually looks something like that. Okay? What they're telling us is that its y-intercept is right there, passes through that point, and they also said it passed through this point up here, 3, 16. What we have to solve for here is A and B. Okay? And we will end up with something like y equals 2 times 3 to the x, or something like that. Okay? Yeah. So your final solution, you always still have your y and your x, but the a and the b are specific for this particular exponential function. Mm-hmm. So, one thing that's easy to solve for is A.
Okay.
If you use this point right there and substitute 0 for x, what do you get for y? Well, first of all, we know what y is, right?
2.
In other words, I can write 2 equals, I don't know what a is yet, but I know what x is. I know what b to the 0th is.
1.
So a is 2.
Okay.
Okay. So now I've solved for a is 2. Let's go to this second point. Can't use the same point. Got to use another point. This is going to let me solve for b. So what should I write using this second point?
Three.
Start with y. In other words, we're always starting there.
Okay, so
What is y?
16.
Yeah. 16 equals, I've solved for a, so I know that a is 2. Haven't solved for b yet, but I'm going to plug in what for x?
3.
Now how do I solve this?
So you divide 16 by 2.
Very good.
And then a equals 2. I mean, yeah, b equals 2.
What's the step that gets you to that?
The cubed root of
Exactly. In other words, what you're doing is you're taking the cube root of both sides.
Yeah.
And whenever you take the cube root of any number being cubed, it's equal to that number.
Yeah.
Okay? In other words, the cube root of 17 cubed is 17. The square root of 17 squared is 17. So those always are true. So we've solved for a and b. What's my final answer?
Y equals 2 times 2 to the power of x.
Now, I usually like putting that in parentheses.
Okay, yeah.
And I'm not sure why. They're not necessary. In other words, the exponent only applies to the number below it.
Yeah.
Or what's usually in parentheses. In other words, if this was 2 times 2 all in parentheses to the x, that's a different number. That's 4 to the x. This is not 4 to the x. That's 2 times 2 to the x, which is not the same as 4 to the x.
Okay.
Okay?
Yeah.
All right. What else?
Okay. So when you're given, okay, so x plus 5 times x minus 2 equals 8. So you have to find the quadratic equation for that.
Okay, did I write it correctly?
Yes.
Okay. What's our first step?
Distribute.
Do they teach you FOIL? Do they call it FOIL?
No.
Oh, really? They don't use that term anymore.
No.
Good. I never really liked it. I prefer ET. What ET means is you multiply every term by every term. In other words, I'm going to multiply that by that, and I'm going to multiply that by that, and then I'm going to multiply this by that, and then I'm going to multiply this by that. And if I had three terms, if I had x plus y plus 5, I would do the same thing. I would make sure I got every term by every term. Okay? So what do you get when you do the first one? The reason it was called FOIL is because that is the first one. That is the outside, that's the inside, and that is the last. FOIL. So what do you get?
So x squared plus negative 2x.
So let's just write minus instead of plus minus.
Yeah. Then 5 plus 5x.
Do you need the plus sign there? Because this is part of a polynomial. I don't put that plus sign, it's not assumed.
And then minus 10.
Okay. Now, whenever you multiply, this is called a linear term because it's x to the power of 1. And this is a linear term. Whenever you multiply a linear term times a linear term, the only x squared you have are in that first term. And the only numbers you have are in that last term.
Which means you just...
terms can always be combined.
Yeah.
Okay, so combine them and simplify it. What do you get?
X squared plus 3x minus 10 equals 8.
Okay, now let's go back up here a second. I've got two things multiplied together equaling 8. Don't know how to solve that. That's impossible to solve.
Yeah.
Because it could be 4 times 2, it could be 1 times 8, it could be all kinds of things. But when you have two things multiplied together equaling 0, now you can solve it. Because if you can separate it into two things multiplied together, you know that one of them has to be 0. So, what's my next step?
You have to set it equal to 0.
Okay, how do I do that? What do I have to do to both sides of the equation?
Subtract it by, add 10.
No. If I'm setting it to 0, I got to get rid of this 8.
So we subtract 8.
Exactly. In other words, so I subtract 8 from both sides.
Okay.
In other words, it's always one side that needs to be 0. And if I move the 10 to the right, well, then I just got that equal to a number again. So it's very important to get it set equal to 0. And what that leaves is this minus 8. Now let's factor that.
Okay.
And remember how we foiled it. Because what factoring is reverse of foiling.
Yeah.
So my first step in foiling was multiplying the x's together. What's my first step in factoring going to be?
Dividing. I mean, like
separating them. Yeah.
Yeah.
Not really dividing. I suppose you could think of it as dividing, but in this case, it's x and x. Notice that when I do the multiplication at the end, it's going to be x squared. So I'm in good shape so far. Now, what's the second step in factoring?
You put plus or minus and then plus or minus on both sides because...
Yeah, and I only need one plus or minus. That's going to be the same as a minus plus, as long as this coefficient of x is the same. If they have different coefficients, then you have to use both. But in this case, they have the same coefficient, so I can get away with just a plus minus. Now, what's the third rule? Verbalize it out loud. Factors of
18, negative 18.
No, let's just work with factors of 18 that do what?
Add together and create the same
No,
number.
it's based on this here. In other words, if that's a minus sign, then these factors have to subtract to this coefficient.
Okay, yeah.
If that was a plus sign, then they would have to add to that coefficient.
Okay.
So that's the rule. Now, what factors of 18 subtract to the number 3?
Six and 3.
6 and 3, okay. So those are our numbers. Now all we have to do is figure out which number goes with which sign. And what's the rule? Where's the 6 go?
The 6 goes to the negative.
No, here's the rule. Take your biggest number of the two factors and put it with the sign of the middle term.
So that's the positive.
That's a positive. So the 6 goes right there.
Okay.
The 3 goes right there. And now what's the solution? X equals what? 2 solutions.
X plus 6 equals 0 and x minus 3 equals 0.
Okay.
So equals negative 6 and x equals positive 3.
There you go. And those are your two solutions. If you were to plug either one of those in, that would be a proper equation.
Okay.
Okay?
Yeah.
All right. Rithika, I'll talk to you again. Maybe, maybe not. You have your quiz coming up soon, don't you?
Yes, on Friday.
On Friday. Okay. Well, I have some time available if you need another appointment. Be happy to give you one.
Okay.
Okay? Otherwise, you have a good night and evening, and good luck on your test.
Okay. Thank you.
You're welcome. Bye-bye.
Bye.